Now we're going to look at some more examples with the rational zero theorem. Specifically, we're going to look at some more complicated ones. So larger polynomials and polynomials where the zeros are not as easy to find as being rational numbers. Again, just as a quick reminder on the vocab from the last video, when I refer to the constant term, that's the number by itself. The leading coefficient means the coefficient in front of the biggest variable's exponent. And then the degree of the polynomial is whatever the biggest exponent is on the variables. So in the last video, I was focusing on degree 3 polynomials. We will look at some that have a degree 4, which means we'll see an x to the 4th power somewhere in the problem. And then when we're talking about the synthetic division vocab, whenever I refer to the quotient, those are the numbers underneath your synthetic division, not counting the remainder. The remainder is that very last number on the end. The 0, if you do get a remainder of 0, no remainder, then that means this number you were testing with synthetic division was a 0. So the information I have here, it's the same step-by-step process we looked at yesterday. The only thing I adjusted is that sometimes you may not be able to factor the expression from your synthetic division, that quotient that was underneath we just looked at. If it cannot be factored, then you'll have to use the quadratic formula instead. So I mentioned here that this is the only difference for the first example I'm going to show. It will not be a factorable expression. We'll use the quadratic formula instead. The steps here are the exact same ones that I showed in the last video, so I wouldn't really recommend rewriting them other than the fact that I mentioned the quadratic formula in it. So here's an example. This one is still a degree 3 polynomial, so I'm still only looking for 3 different answers on this. The way we need to begin this is by looking for the list of possible zeros. So I'm going to write this up here in the corner just so I have a little bit more space for the question itself. Now remember, the possible zeros come from the factors of the constant term. So in this case, the factors of 3 are just 1 and 3, divided by the factors of the leading coefficient. And if you don't see a number in front on the biggest exponent, then that means that that number is a 1. So this is actually a very small list of possible numbers to test. And that's because all of the zeros won't be rational answers. That's what's going to happen on this one. So the list of numbers is actually just 1 over 1 and 3 over 1. Which means I have 4 numbers total because I am counting both the positive and the negative versions of those numbers. Now remember, if you pick a number from that list and the remainder is not 0, then you just need to erase that work or scratch it out and then pick a different number from the list. On this problem, I'm going to start off by testing -3. So -3 is one of the numbers on my list of possible zeros, and my list of coefficients is 1, 7, 11, and -3. Now the first number on the synthetic division always comes straight down. Then you multiply by your 0 that you're testing, add the numbers in the column, multiply, add, multiply, add. Now remember, the last number is the remainder, so that means that this is in fact a 0 of the polynomial. -3 is a 0. The problem is, if I try to factor this expression, I'm not going to be able to get any answers out of it because the zeros are not rational numbers this time. So whenever this happens, we need to instead rely on our quadratic formula. This is the a, b, and c values when we're setting up that x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. Now we will need to simplify this a little bit. So the -4, I'm going to bring this over around here to the top, is just going to be a -4 out front. The 4 squared will be 16. Be careful on the signs right here. It's very easy to make a mistake on this. We're doing -4 times 1, which is -4, times another -1, which flips it to a +4. And in the denominator, 2 times 1 is 2. So the square root of 20, you can think of that as 4 times 5. 16 plus 4 is 20, and 20 is 4 times 5. And the reason I'm doing that is because I know that 4 is a perfect square. So I can take the 2 outside of this radical, and then I also notice that all of my terms are divisible by 2. So this fraction can be reduced by dividing all 3 of my terms here by 2. I know it can be a little confusing. We only divide the number in front of the radical, the coefficient essentially. We only divide that number by the 2. You're not dividing the number inside the radical. So numbers inside of radicals and numbers outside of radicals do not really interact in any way there. So my last two answers are the -2 and the plus or minus root 5, because -2 plus root 5 is one of the zeros, and -2 minus 5 is the other 0. The first 0 that we found was that -3. So altogether, my three answers, just to write them out, my three solutions were -3 and -2 plus or minus root 5. So if you cannot figure out how to factor the quotient from your synthetic division, it may not be factorable, in which case you just need to rely on the quadratic formula. Now let's talk about the degree 4 polynomials. So for the degree 4 polynomials, the difference on this is going to be that we need to find two numbers that are zeros by using the synthetic division process. Now you'll notice I also changed this to finding the real zeros, not the rational zeros. Whenever you see them specify real, that's kind of a good hint that your answers might not be numbers that can be written as fractions. So you're probably going to have square roots in your answers. So that is a good thing to keep in mind when you're doing these problems and looking at the directions. So we're still going to make our list of possible zeros, same way we've been doing. Then we're going to use synthetic division. We're going to test numbers until we find one without a remainder. That'll be our first zero. Then we're going to go back and we're going to keep drawing numbers from our list of possible zeros. Now the easiest thing to make a mistake on here is you need to be doing the synthetic division to the quotient from your first synthetic division. Don't go back to the original question when you're trying to find a second zero using synthetic division. And then once you've finished that step, to find the last two, you can go back to either factoring or using the quadratic formula. So here's our example. This is a degree 4 polynomial because I see that there is an x to the 4th power in it. So that's why I'm going to come into this expecting to find 4 answers this time. Now to begin with our list of possible zeros, we have plus or minus. The factors of my constant term are 1, 2, 4, and 8. The factors of my leading coefficient are just 1 and 2. Remember, we need to make all the possible fractions out of this that we can. So I can do 1 over 1, 1 over 2, 2 over 1. 2 over 2 is 1. We've already written that number, so I don't need to write it again. 4 over 1 is a new number. 4 over 2 is equal to 2. That number is also already in my list, so I don't need to write it again. And then 8 over 1 is a new number. But 8 over 2 has already been added to our list. 8 over 2 is 4, and we already have that one on there. So this is our list. Now there are a couple fractions, but hopefully it's not going to be one of those numbers. So instead we're going to start off and we're going to go through testing different values from our list of zeros, our possible zeros here. I'm going to start with the number 4. My coefficients are 2, -7, -8, 14, and 8. First number comes down. Multiply, add, multiply, add, multiply, add, and multiply one more time, add. So there is one of our zeros. Now you'll notice this time we have 4 other numbers. That's why we're not ready to switch to factoring or the quadratic formula at this point. So what I have to do is I have to keep using numbers from this list. Now as a word of warning, it could have even been 4 a second time. So just because a number worked once doesn't mean it won't work again. But if you already tested a number like 1 and found that it doesn't work, then you don't need to test 1 again. So a number that works might work twice. A number that didn't work will not work again later on. So now I need to find a second number from this list. I do want to show you one where one of the fractions is actually the correct answer. So this time I'm going to test -1/2. So we need to find a second zero using synthetic division. This time I'm not going to come back to the original coefficients. I'm going to come down to my quotient from the first zero that I found. So I'm going to use these numbers, 2, 1, -4, and -2. This is what we need to test on now. So the first number comes straight down. Half of 2 is 1, but it's a negative, so it's going to flip the sign on it. Add the numbers. Multiplying by 0 is always still 0. Add the numbers in the column. Half of 4 is 2, but we're changing the sign, so it becomes a positive. And then adding the numbers in the column makes it a 0. So there is our second zero. So now that I have it down to just 3 numbers in the quotient, now I can switch to trying to factor this or use the quadratic formula. Now something special actually happens in this very rare case. When the middle number, the b value, is a 0, there's actually a third option you can use for solving. So if this number wasn't 0, then just factor or use the quadratic formula. But when this happens, you can take a little bit of a shortcut by writing down the polynomial that you have, so 2x squared plus 0x minus 4 equals 0. This can actually just be solved by using opposite operations. So if I add the 4 to the other side of the equation, and then divide both sides of the equation by 2, now I can take the square root of both sides. Square roots and squares are opposite operations. So by square rooting both sides of the equation, don't forget that gives you a plus or minus answer. So there's going to be 2 answers out of this. So plus or minus square root of 2. Square root of 2 doesn't reduce, so that is the last 2 zeros. So altogether, the 4 zeros for my polynomial are 4. That was the first one I found. Negative 1/2. So those are the ones I got from synthetic division. And then the other 2 answers that I got from using opposite operations. But like I said, you absolutely could have used the quadratic formula. You would have gotten the same answer if you did that correctly. So the last 2 answers for me were the plus or minus root 2. Those are my 4 solutions from using for finding all of the real zeros of the polynomial. Notice that 2 of them were rational numbers. 2 of them were numbers that could be written in fraction form, but 2 of them were not numbers I could have written as a fraction. That's why this one is saying find the real zeros. So when they mention real zeros in the directions, that is a good hint that some of your answers might be square roots. Keep that in mind. And that's it for the lesson.